mode.
Hello, everyone, and welcome. John Resso with Wells Darby. In the background, we got a crew of people: Rob, Jim, James, running the questions and doing everything on the back side here. So today we're going to go over all about Tankless. Name of the class: all about Tankless. We'll give you some history of Tankless, where it was, where it is, where it's going. We are going to go through, and we have a cutaway unit here. I have all the parts and pieces for this unit. We're going to go through each part and piece, tell you where it is, what it does, why it's there, and cover all of that. On your screen, on the right-hand side, you probably have a little arrow at the top. If you don't have the whole control bar open, you can open that up, and there's a question bar in there. You can click on the question bar, and if you have questions throughout the class, please don't hesitate, ask. Rob will be grabbing the questions. He may bring a couple on live. He may answer them all privately. Doesn't matter. So without further ado, we will get started. I always start this with, what's the difference between a tank style water heater and a tankless water heater, right? Because that's really the fundamental differences that we need to understand before we go to a tankless type product. So I got up early this morning. I took and hopped in the shower. Let's say I have a tank style water heater. I got in the shower. I started to draw water off of the water heater, and the water heater started to take on cold water from the home. When that took place, it took the control and told the control there was a water draw by dropping the temperature of the control. It fired the unit, and the unit ran probably the whole time I was in the shower. I got done. I shut the faucet off, shower head off, and the tank style water heater probably continued to operate until it made temperature. And that could be 1 to 5 minutes, whatever it is, to make temperature. So I left early this morning. Throughout the whole day today, when I'm not home, that water heater will cycle 2 or 3 times throughout the day to maintain temperature within the tank. Okay, when I get home tonight, I'll do dinner, whatever, open the faucets, and the water heater will go through its normal procedure. I go to bed, and it will cycle a couple times throughout the evening into the night and maintain our target temperature of our aquastat control on the tank style water heater. So that's the life of a tank style water heater, right? So tankless, how would that tankless react in the same scenario? So I get up in the morning and I basically get in the shower. As soon as I get in the shower, turn the faucets on. As soon as I do that, tankless recognizes flow. So as soon as I recognize flow, and with this unit, it needs to be a half a gallon of flow. Most units in our industry are right there, 0.4, 0.6, in that range. So when that happens, basically what will go on is the unit will fire and we will start to produce hot water. The difference is this will fire and then it will modulate down to the correct BTU to support the load of that one shower. Tank style fires at full capacity all the time, every time, doesn't know any different, doesn't modulate. This will modulate to match the load of the shower at that moment. I'll take my shower. As soon as I shut the shower faucets off, this will shut down. I will leave for work. If no one touches a water faucet all day long in the house for hot water, this will not run. When I get home, as I start to draw water off again, it will fire and it will support the water that I need for the house. So that's the fundamental differences. The tank style water heater will run throughout the day, throughout that 24-hour period we spoke about. The tankless will only operate when there is a demand, if it's a gas tankless. Now, we also offer a electric tankless. So these come in 1, 2, and 4 chamber tankless style units. So this, no volume?
No, I fucked up.
All right, hang on, we'll wait. You good?
Now we're showing the screen.
Oh, now we're showing screen?
Yeah,
All right, that's fine. We were just
again.
talking, that's fine.
Bad.
So sorry about that. I know we weren't sharing screen, now we are. So electric tankless, this will do the same thing. the difference here is this has a little like trickle charge that will keep the chamber in here warm so that the electric has the ability to keep up with your demand. And depending on the size of the unit, you can get up to 3.1 gallons a minute out of a electric tankless. So we'll just touch on that a little bit as we roll through here, just so you get again all about tankless. So let's just give you some history of our industry. So there's about 9.2 million tank style units shipped every year. Okay, out of that, 20% go into new homes, 80% are replacement units, 30% are complete failures, and about 27 million water heaters are over 10 years old. And that's kind of the target number for a tank style water heater is 10 years. So the market, our US market, the US market shows the incline of electric tankless and gas tankless. And that market shows by about 2025, we should be over that million mark of tankless water heaters installed. So that's where this is trending. And that's kind of where what everyone is seeing right now. We're trending towards a million water heaters, and it's growing every year. About 7% of tankless units are installed into a renovation type situation. You have someone has a water heater that fails and they want a tankless unit. That usually takes a little bit of time to do so, planning, but that's about where 7% of the tankless units go. So that means 93% go into new construction. When these go into new construction, they usually go in, a couple hundred at a time, multifamily type situations. So that's where these are being used. So I want to make sure everyone understands where we're at. So if you haven't done a tankless before, it's obviously extremely important to take a look at the manual. There's a lot of nuances about all these different tankless that are out there. Understand the brand that you're using. Again, we're the A.O. Smith guys, so we appreciate you using ours. But whatever you're using, just make sure you're checking to see that everything you're doing is correct to the manufacturer's specifications. So on the electric side, we talked about earlier, so we have 208 volt, we have 230 volt electric tankless in 1 chamber, 2 chamber, and 4 chamber. And I'll show you what one of these looks like. So I showed you the one with the jacket on there, look nice, neat, and clean. This is the actual tankless unit, electric tankless. So you have a few control boards. Your power inlet goes here. We have multiple connections to the element. This is a DuPont material which resists any minerals or anything from attaching to it. Pretty cool here. If you really want to know what's going on inside the heater, you can take this off. It's got a rubber O-ring. You can get, if there is any sediment buildup. And this is different in the electric tankless world. We use a standard style element. Okay, so if you're used to doing electric water heaters, tank style water heaters, we use the same style. Majority of the manufacturers out there use basically if you ever worked on a appliance dryer and you got the springs that go around for the electric heat, that's what most manufacturers use in electric tank style or electric tankless water heaters. So another real neat feature with our electric tankless is right here, this little brass screw. If you're in the boiler world and you deal with low water cutoffs, that's what this little brass screw does. This kills the element if it sees air, if it has a break in contact. So we're getting basically a ground signal to the water. It says there's water, the chamber's full of water. We're not going to dry fire the element, and that allows us to protect that heating element. That's like a major part that fails, not a major part, but that's what fails in tankless electric is the heating elements, because you'll get an air bubble that goes across them and the temperature on them is pretty hot and they'll pop. So main reason we go with this type of element, it's more robust. We protect the element with a little grounding screw here that will tell us if there's water in the in the element itself, around the element, I should say. And in addition to that, we're taking our temperatures here, thermistors, thermistor, thermistor. That's what tells us when there's a water demand, when the house is looking for water. The other thing we're able to do here in the boards, it's built into the boards, we're able to trickle charge the water to keep it warm. And that also will flake off any scale that may attach itself to the heating element. And they come with these brass adapters that basically screw directly onto the top to transition you from the DuPont material to a brass fitting so you can go ahead and plumb it into the home. So that's just a brief overview. We're talking anywhere from 12.2 kW to 32 kW. And if you really want to do the math, if you're trying to replace some type of a unit, if you know the BTU of the unit, you take your kW. The kW is worth 1312, 1313, depends on where you're looking, BTU. So take your 12.2 kW, multiply it by 1313. That will tell you the BTU of this unit. And then usually in the tankless world, we look at a 70-degree temperature rise. And that's usually where we get our flow rates from in the tankless world, the 70-degree rise. On the tank style, we normally look at a 100-degree rise. Okay, so we'll keep rolling forward. We're going to transition from the electric to the gas, and we're going to dive in here. So if you're out there speccing tankless, it's always important to know what am I up against, right? What do I have to do to support the demands and expectations of the homeowner? So we need to understand the temperature of the water coming in. And in our region, we can be anywhere from 37 to 51-ish degrees in our footprint for groundwater. So we need to know that when we're speccing out a tankless unit, whether it's electric or gas, because we have to have the ability to elevate that temperature, leaving the ground, coming into our home, elevate it to call it 120 degrees, and then deliver it to the appliances within the home, showers, washers, dishwashers, whatever. So our area, that this New Jersey, New York, Lower Hudson Valley area, that's where we cover. We have hard water here, so the brand really doesn't matter to me. All tankless heaters are basically, if you have hard water, they're just not going to last. You have to get them serviced. So what we do with ours is we recommend, this is called a product preserver, and it gives you the ability to screw it to the wall. Comes with a wrench to take it apart. And I'll just take this apart. This is good for 7 gallons per minute. And what we do is we put this on the cold water main coming into the tankless unit. Goes through this. We've got a cartridge in there. Cartridge has a bed in there. And what that does is that'll take the hard molecules, and the crystals that are coming, not molecules, the crystals that are coming through, and it will trick the crystals, basically coat the crystals, and allow them to pass directly through a tankless water heater. So they're not going to attach themselves to the heat exchanger, create hot spots in the heat exchanger, and create a heat exchanger failure. This will be good for 2 years. After 2 years, you're going to want to take and change out the cartridge, the inside cartridge, and always check your flow rate. And we'll touch on that a little bit later as we go through this program. I'll give you, what we use as some pointers as to what the flow rates are and what they should be. So hard water, 17 to 50 parts per million, 1 to 3 grains per gallon. That's really where we're at. So we want to address it. The other side of it is we always want to look at the pH and see where the pH is. We want to live in that 7 range with pH. Pressure drop across the heat exchangers. These are what you're looking at here. These are both condensing heaters. So condensing heaters have 2 heat exchangers. Non-condensing heaters have 1 heat exchanger. If you're going to put a tankless style heater into a situation where there's a well, homeowner has a well to support their home for water, domestic water, you would probably want to stick to the non-condensing version. Based on the pressure switch and the pressure drop across a tankless water heater, you're going to want to probably stick to a non-condensing because the pressure drop is much lower, and that will work better with the 20, 40, 30, 50 well tank that they have within the home. So always look at that, look at the water conditions if you're going to put it into a situation where it's going into a well type application, because we want to know that pH and we want to make sure what we're putting through these heaters. And the main reason for that product preserver is we want to keep the heat exchanger clean. And the cleaner we keep the heat exchanger, the more performance we get out of it, and the longer life we will get out of the heater. And again, brand X, Y, or Z. Okay, gas side, 140,000 BTU, 160,000 BTU, 180,000 BTU, 199,000 BTU. They all modulate down to either 15 or 13,000 at the bottom, depending on if it's natural gas or propane. The units we're going to look at today, these are both the ATI 540s. So these are 199,000 BTU units that we're going to talk about today. All the parts and pieces I have in front of me are out of a ATI 540, 199,000 BTU unit. So these are fully modulating. They will modulate from that 13 or 15,000 at the bottom, everywhere in between up to 199. This is not step modulation. It is a true modulation. We also have a CT 199. That is our commercial version of our smaller units. It's basically like this, looks just like this unit. Some of the internal components are different. It's a CT 199. It's for commercial applications. This is an ATI 540. This is for residential type applications. Just brief overview. PVC, stainless steel, or polypro venting. Polypro is probably your best venting option right now. Centrotherm, right off the top, they make an adapter. Centrotherm right off the top, it's going to be less expensive currently than PVC. So there's your venting options, up to 100 feet, depending on the size. This unit vents in 3 and 4 inch, and that's all going to be in the manual. I'm not going to go through every venting distance and such. We're going to go through, spend more time going through the components. Temperature range, out of the box, they're all set at 120. And we have the ability with different controls to get to 180. We can get to 160, 180. Standard one out of the box, plain vanilla, will get you to 140. The connection points on the units, they're all on the bottom. So the cold water inlet is here. The hot water outlet is here. The gas is here. The condensate is over here to the right. So pretty basic. All of your connection points, as far as mechanical connection points, are going to be at the bottom. Your venting connection points will be at the top. We have indoor and outdoor units. This happens to be an indoor unit. We do have these for outdoor use. There would be a vent termination right here on the outdoor use ones, and don't expect them to, live outside at 0 degrees. They just won't last. We do have some heaters strategically placed throughout the inside of the unit, but again, don't think they're going to keep it from freezing. It is strongly recommended on every job. Product preserver, valve kit on every job. The reason for that is we want to make sure that we have the ability to service the unit. If the unit needs to be serviced, we have the ability to flush the heat exchanger. Primary heat exchanger is here, this copper heat exchanger. The secondary heat exchanger is here, the stainless steel heat exchanger. We want to make sure we have the ability to flush them. You would use a vinegar, a real light chemical, and make sure you flush it out when after you do it. And we'll touch on the process at the end. Never a bad idea. We have a screw thread here to put a neutralizer. We do come out of here slightly acidic, so it's never a bad idea to have a neutralizer. Expansion tanks. Most tankless units don't have expansion tanks because we don't store water, but there are some inspectors that are looking for them. and we have a nice little expansion tank that we partner up with Tankless water heaters. Flow rates on these, basically, if we're talking, you know, a small condominium, one person, maybe two people, not a lot of hot water use, you can get away with the 140. That'll get us about 3.1 gallons a minute at a 70-degree rise. If we step up and go to the 240, that's the 160,000 BTU unit. That's going to get us at a 70-degree rise. That's going to get us about 4.2, 4.3 gallons of hot water per minute. And if we step up to the next level, which is 180,000 BTU unit, that's going to get us up in that 5.2, 5.0 range. And if we get all the way up to the 199s, the version that we're looking at here, that's going to get us up into that 5.4 range. And that's at a 70-degree rise. So, you know, if I have warmer water in the summer coming out, obviously my flow rates are going to go up higher. These are rated at 10 gallons a minute with a 30-degree rise. So as we get higher elevation of water temperature, we got to go from 40 to 120. You know, that's when we start to see those 5-gallon, 5.4 flow rates. CT199 will give us the same performance. All right, so now we're going to jump into how does this thing work, what makes it tick, and so on. So I have this tankless water heater in my home. I take and open a faucet. When I open up that faucet, I create more than a half a gallon of flow. As I create more than half of a gallon of flow, internally, we're going to enter through this valve. This is our cold water valve right here. That cold water valve has two things. It has a yellow wire, that's a block heater. It has a black wire, that is a thermistor. So if I go to this control and I go to this information button and I push it, that's my target temperature of 120. If I push it again, you'll see a little arrow go right here. It says 52 degrees. This thermistor wire right here, that's what's sensing 52 degrees. So the unit knows the temperature of the water entering. So it will fire and match the demand that it needs based upon the inlet water temperature and the exiting water temperature, our target temperature of 120. So standard thread, standard 3/4 thread. You can't see a bunch of this valve from here up. It's inside of the cabinet. Make sure you back this up when you're putting your fitting on. We also have here, we have an internal screen. Okay, that screen is there to catch debris, and that screen can come off to be cleaned. You pop it back on. The rubber O-ring is reusable. You don't need channel locks to tighten this up. You can put it in and you're good to go. In the center, there's a Phillips head screw. That Phillips head screw is removed. The thermistor will come out and the heater block will come out. The heater block is in a dry port. The thermistor is in a wet port. There's an O-ring on the inside of the thermistor. So if you have to change out this thermistor, you have to shut off your mains and drain it in order to pull the thermistor out. So back out the Phillips head screw. This will come out and it can be replaced. This is nothing more than an ohm value. And ohms, I can't give you the ohm value because it'll be based on temperature. Okay, so that's the cold water inlet. That's where our water comes in, enters the heater. So the water enters the heater, it then hits a flow valve. This flow valve is what's going to gauge the flow, hence its name. This plugs directly into the board. There's a little impeller in there. And as the water runs across the impeller, it rotates. As that rotates, there's a magnetic pickup. So it's a plastic impeller inside of a plastic flow switch. We rotate around based on how many hits on the magnet, the unit knows the flow rate. How do we know this is working? Well, we can go here to the control, and if we hit the information button 3 times, that will give us the flow rate of the unit at that moment. Now, flow switch, if this does not recognize flow, it cannot give you an error code. Okay, I'm going to say that again because a lot of guys, it's confusing because they know there's water going through the unit, but the unit's not firing and there's no error code. All right. If this does not rotate, or it's rotating and it's not counting how many times it's rotating, the unit doesn't know there's water flowing across it. So the unit cannot give you an error code. Okay, the job of the flow switch, register flow, let the control board know what the flow is. The control board will then decide what BTU input we need to run at to support that demand. So that's the job of the flow switch. No error code, unit not running. You get to the job site. First thing you're going to do, obviously you'll try to run it. You'll shut the power off. You'll shut your mains. You're going to open this up. You're going to check your screen first. And if that's perfectly clear, you're going to leave your mains off. You can take your control and just lift it out of your way. Set it off to the side. Right here behind these wires. Right here is the flow switch. You don't need tools. There's little clips. Clip here and a clip here. The flow switch can come out of the unit. The wire can stay attached. You can power it back up with your mains still off. Hit your info button till you get the flow. You can blow into the flow meter and see if it registers flow. If it registers flow, you know the flow meter is working. It's something else. If it does not register flow, you know your flow meter has failed and you need to replace your flow meter. Okay, so that's a pretty easy check. Really no tools, a Phillips head screwdriver to take the cover off. Okay, so that's the job of the flow switch. That's what's in there. That's what it does. 2 Molex connectors. There is some other ways to check this if need be, but I gave you the basic, real easy, simple, let's get this thing checked out and move forward method of checking the flow switch. So we enter through the cold, we go into the flow switch, we leave the flow switch and we come up to this port right here. It might be difficult for you to see, but there's a T block here. One side has a bypass. One side goes directly up into the secondary heat exchanger. So this is the secondary heat exchanger. This is a cutaway. It is in the unit just like that. There's your connection points. So the cold water goes directly into here. The water runs through the inside of these tubes and comes out here and goes down and around into the primary heat exchanger right here. So in that secondary heat exchanger location, our flue gases are passing by the outside. So combustion happens here. It goes over the primary heat exchanger first. We extract about 60% of the energy out of the flue gases. It transfers into the secondary heat exchanger. The flue gases pass this stainless steel heat exchanger. This is 3/16 L stainless steel because this is where all the condensing should take place. We'll go by this, the coldest water quenches and cools down that flue gas. We create condensation. Every gallon of condensation, you're saving 8,080 BTU, keeping it in the home. And the flue gases, after they pass over this heat exchanger, will exit out through the exhaust. So water pattern again, in the cold, up into the secondary heat exchanger first, comes over here to the end of the bulkhead, turns around, and goes back the other side of the bulkhead, comes down, around, and starts to wrap around the back of the heat exchanger. And we're taking the temperature right here with the thermistor as it's going through the heat exchanger, goes through this heat exchanger, comes out the other side hot. And on the 540 only, we have what's called a bypass valve. What that bypass valve is doing is it's getting a signal from the control. And the control is telling it based on some thermistor settings. You know, we're getting a thermistor reading here. We have a override clicks on thermistor on the heat exchanger. So we're taking some temperatures of the water as it's flowing through the heat exchanger, and this may open a little bit and mix some cool water in if we're over target, or it will close and allow it to run at normal. If you're working on a A.O. Smith ATI 540 and you want to flush the heat exchangers, you have to elevate the target temperature up to 140. At 140, you'll get this valve to open. After you get that valve to open, when you hit 140 degrees, shut the unit down right here. Shut the unit down. This will stay open, and then you'll have the ability to flush the primary heat exchanger and the secondary heat exchanger. If you don't elevate that temperature to 100, over 120, 140 in that range, this will stay closed, and you're only going to have access to the primary heat exchanger. But that's only on the 540 and the CT 199. They're the ones with the bypass valve. The 140, 240, 340 don't have the bypass valve. You don't have to worry about elevating the temperature. Okay, so that's the flow switch. So we go in, up, around, through the heat exchanger, come out of the heat exchanger, right there where the bypass is, the T, and then we send the hot water down. The hot water comes down and it exits the unit through this valve. And this valve, again, has the block heater and the thermistor. This is the final thermistor. This is what we're targeting when we set this control. This control is set to 120. Get back. It's set to 120. The unit is in standby. This is the last opportunity we have to sense temperature. This is what we're sensing, 120 degrees leaving the unit. How are we doing on questions, Rob?
Good right now.
Good?
Yeah.
Okay. So that's the water circuit through the unit. That's how the water flows. That's how the water is seen by the flow switch. On the larger units, again, that's where we mix down if need be, through the secondary heat exchanger first, back through the primary heat exchanger, out through the bottom, exiting the unit. Okay? Let me just catch up here. I got a little cheat sheet I'm looking at here on the side. So we'll go now and we're going to talk about the gas side of things. We have a gas inlet right here. It's critically important that you back that up when you put your gas valve on. It is critically important because we have had a couple guys twist this and had gas leaks at the unit. So make sure we twist that. Make sure we get it in place. Everything is good. Use your, thread compounds and so on. If you're going to do a pressure check on the unit, you have to make sure that the gas valve is off. There are 5 solenoids on the back side of the gas valve. If you do not shut the gas pressure off and you pressurize to 5 psi or whatever number you use, it will blow the O-rings out of the gas valve. So I want to give you, our group, our contractor services group, we're on jobs constantly. We're sharing what we have seen in the field. Okay, if a guy forgets to close this valve, it's a problem. If a guy doesn't back this gas valve up when he tightens it, it's a problem. So just be aware. So this right here is the gas valve. This is a cutaway. There are 3 gas tracks, 1, 2, 3. The center one right here, directly below the igniter and the flame rod, that's the one that will be running the most. A.O. Smith does something a little bit different here. When we see a demand of water, we automatically fire to maximum input. So this unit, 199, we're going to fire to 199, and we're going to get the water up to your target temperature as fast as possible. Then what we'll do is we'll back it down, and we'll back it down to marry up to whatever the demand is. So 1, 2, 3 tracks. We also never shut the gas off when there's a demand. So we could have all 3 tracks on, but really we need 1.5 gallons of water, hot water. we'll step it down to marry up to whatever we need, one gas track. So if this gas track is on and it's supporting the demand, and then there's another demand, it will pull on gas track 2. And if there's still a larger demand, it will pull on gas track 3, then it'll shut off 2. And then if it's a full demand, it'll pull 2 back on. So if it's a full demand, all 3 will be on. If it's a partial demand, it could be 1, it could be 1 and 2, it could be 1 and 3, depending on the demand. In the gas track, I said earlier, there's 5 solenoids on the back. 1 solenoid is for each gas track. We have a main gas valve there, solenoid gas valve, and we also have a proportional gas valve there. So what that proportional valve does is it adjusts and modulates the gas input. That's why I said we're fully modulation, even though when you look at this, there's 3 solenoids, you may think it's step modulation because there's 3 solenoids. But because of the proportional valve, we're able to modulate between each one of those ranges. So we're full modulation from, I'll call it 15,000 to 199,000 on this unit. On the gas valve side, I am going to just shut this unit down, and hopefully we're outside. So hopefully you'll be able to hear this. Every time you turn the unit on, I'm not sure if you heard the gas valves. Can't hear the gas valves? Okay. You'll hear the gas valves. The solenoids will clunk. So I just wanted to try to show you, but again, we're outside, so it's too loud out here to hear it. But when you're in a boiler room, wherever your water heater is, the very first time you turn that on, and every time you turn it on, you're going to hear the gas valves clunk. So at the bottom, again, we have the neutralizer, where your neutralizer is going to go for your condensate, your gas, your cold water in, your cold water out. And the first time you go to turn this on, all the way over to the right, there's a little black bleeder there. You're going to open up that black bleeder port, and that is going to make sure all the air gets out. This little copper line right here, this is attached to the bleeder port. What that's going to do is we're going to make sure we have all the air out of the piping, all the air out of the primary heat exchanger before you fire it, so you don't dry fire. You have the opportunity right under here to take the little plastic port, open it up, and then close it when you're done. All right, we're through all that. Good. So we follow that gas up and in. We need to ignite that gas. Our igniter is right over here. This is what the ignition system looks like. That mounts right here on the side of the unit, 1 Phillips head screw. Our igniter, give you a little better view, goes directly into, this is the front of the burner. So the igniter goes here. There's a sight glass here. You can see the flame. And then over here will be your, what we call a flame rod and an air fuel ratio rod. And what that air fuel ratio rod does, it monitors the temperature of the flame, and it will make adjustments on the fly. So if we don't have perfect combustion, it will either open up the proportional valve a little bit if it needs more gas, or it will take and speed up the blower motor or reduce the blower motor depending on what's going on for combustion. And it will make those, you don't have to do anything. You don't have to set that up. That's built into the unit. It's going to do it on its own. If it cannot get the flame within range, little kid next door put a couple tennis balls into your exhaust or something, it will eventually say, hey, I can't get this flame into range, and it will shut off and give you some type of an error code, probably a 111 error code or a block flue error code. So this igniter goes in here, it sparks directly to the burner. These are 16 individual burners. So on that gas valve setup, you have 16 gas nozzles and air nozzles on there. So this is not a pre-mix. We actually inject. It looks like a bunch of orifices setting right here. We inject the gas in, we pull the air in with it, and it mixes on top of the burner, and you'll have normal burner flames off of here. It's not like the high intensity glow like you'll see in a high efficiency boiler. We're still 95% efficient, but you'll have a standard style burn going on here. If you're in the field and you have a unit that maybe, you know, it's in a dusty situation, or there's sheetrock dust in the room, if you have to pull this burner tray out to clean it, it's critically important to get all of these are air holes around the burner tray. You want to make sure that that whole area is clean so that you get proper combustion when you put it back together. This is the flame rod. The long one is the flame rod. The short one is the AFR, air fuel ratio rod. They will insert directly into this position. And when it's in position, you know, this is what it will look like when it's in. And again, that will babysit the flame. To take those out, there are 3 Phillips head screws. There's a white gasket behind there. If you're extremely careful with the gasket, it will stay together. If it tears, you'll have to end up with a new one. Do what you got to do to, you know, make sure that is sealed. If you take this burner tray out, you're going to wash it with soap and water. You'll blow it out after you're done. Make sure you have all the water out of it. It's dry, ready to go back in. Keep your eye, make sure that glass is still in there, the little sight glass. It locks in, but just check it. I've seen one of those fall out with, you know, when a guy was washing it. I just always make sure that's in there, because we would put combusted air into the space. So gas train here, if this ever had to be replaced, it's about 8 screws right along here, and then there's one down the bottom. Yeah, you take your solenoid wires off, this will lift right out, and it's replaceable. You don't have to tear the whole unit apart to do that. If you need to pull the burner tray, you'll take those same screws out, and then there's a few more screws along here. You'll remove this cover plate for your igniter and your flame rod, and then your whole burner tray will slip out, and then that can be cleaned. And then you can inspect the bottom side of the primary heat exchanger if needed. You will need a gasket kit for that. So if you're going to make those changes, just be prepared to have a gasket kit. After we go through our gas train, we have our burner here. We have the flame on top of the burner. That's going across the primary heat exchanger. That's going to the secondary heat exchanger and out of our exhaust. We monitor that whole system in a couple of different locations. Okay, we take right here, we have, this is a clicks-on sensor. This is a 157-degree sensor. This is an automatic reset. So if for some reason we had a tremendous amount of wind outside and someone was using the tankless water heater and the sensor felt 157 degrees, it would shut the unit down. It would do an auto reset. And after the auto reset, Timber, it's windy out. After the auto reset, the unit would fire back up on its own. So protecting the PVC pipe, or, you know, polypro would be fine. Stainless steel would be fine. The PVC is really what they're trying to protect. We also have another thermistor here, 176-degree thermistor. If this were to fail, we have 2 of them here to monitor what's going on within the 2 units. So we always make sure we're protecting the system. Also on the safety circuit side, any blue wire that you see, this blue wire wraps all the way around the heat exchanger. That blue wire connects to a clicks-on thermistor here, not a thermistor, I'm sorry, a little reset clicks on. If we overheat the heat exchanger, this little red button will pop out and you'll get a service call. So what that's telling us is either on the water side or on the combustion side, we're dirty and we need to be cleaned. So we're monitoring the temperature on the heat exchanger at all times. And if there were a failure, a gasket failure, you had a flame blowout or something like that, this blue wire would melt and it will shut the gas valve off first, and then it will shut the unit down. So that's the safety side of the of the unit on the combustion, to babysit the combustion temperatures, to babysit the heat exchangers, and to make sure that everything is running and operating properly. In addition to the safety side, we have built in, these are the block heaters I mentioned earlier, and you also seen on the inlet valve and outlet valve, these yellow wires. Okay, we condense. This is our condensate trap. That also has a yellow wire. Condensate goes right here. All of the condensing should happen in the secondary heat exchanger. It will condense. It will run down into this trough. It will come out, go down through a trap, and it will set right here. The trap will have water in there. So yellow wire on the trap. This is a heated trap to make sure that, we don't freeze here and know everything that's going on. All of these yellow wires will come on at 36.5 degrees, and they will shut back off again at 46.4 degrees. What tells these yellow wires to come on? There's a sensor right here on the cold air inlet. This little black wire right here goes up to this black sensor. That is what tells the yellow wires to activate. And they will activate again at that 36.5 degrees. Every yellow wire on here, these block heaters, block heater, little porcelain heaters, they're all going to turn on, and they're going to take and trickle some heat into those pipes. Because again, I left this morning. If it was colder out, below freezing, that heater is not going to run all day long. And if I have wind pounding on my fresh air inlet, I could be dumping all of that cold air into this chamber of the cabinet, and we're monitoring that. If it gets down below that 36.5, we're just going to make sure we turn that on, keep it a little bit warm, and go from there. That is on the yellow wire. That's the safety side. Again, on the trap, we have it on the trap. That is our sensor. 3-inch PVC couplings come with this unit. The 3-inch PVC coupling tucks down inside if you're going to use PVC. Again, there's a resin shortage right now in the US, so PVC may not be your best venting option. Polypro is a good option. You get the Polypro adapter. Boom, Centrotherm adapter slides right in. Vent it out with Centrotherm. These units, from a venting standpoint, they can be vented 1 pipe, 2 pipe, side of the home, up through the roof, concentric, a bunch of different ways to vent them. Just keep in mind, and we run into this not often, but we run into it a bunch, where they'll want to vent with 1 pipe. Okay, great. But picture a 199,000 BTU unit. Picture the homeowner's basement being 2 empty 53-foot long tractor trailer beds. If you have that much space in the homeowner's basement, you're fine, 1 pipe, because they have enough air within the building to support combustion. If you don't have that, your best option is always to do 2 pipe. Best option is always to put them in the same atmospheric pressure zone and try to have like pipes. 1 elbow and out, 1 elbow and out, 2 elbows, 2 elbows, whichever it is. Again, 75 feet with 3-inch, depending on how many elbows you have. We usually limit this to 5 elbows, and you can go up to 100 feet with 4-inch pipe. So you come out of here, increase the 4-inch, and make your runs. Different termination options. Go to the manual based on your installation. Take a look at your installation, see what it's going to look like, see where your vent terminations need to go, whether it's going to be straight up through the roof. You're going to leave your vent straight up. You're going to snorkel over your air intake. It'll depend on the installation, what it will look like. So venting is key. So just please pay attention to venting. On this unit, it comes out of the box ready to vent between 0 and 25 feet. If you go beyond 25 feet, there's dip switches here in the control. In the manual, it will tell you what dip switch to change based on your venting distances. So if your venting distance is full, you're going to go in there, you're going to make a couple dip switch changes, and that will automatically, it's going to take the blower and it's going to increase the blower's capability to offset the additional friction of the PVC, polypro, central therm pipe, whatever it is. It will offset that additional footage. Elbows, long way elbows. That's what you want to use when you're venting, heating equipment, hot water heating equipment. We're going to use long way elbows. It's a smoother bend, doesn't create as much equivalent feet of pipe. So make your dip switch changes, let that marry up to your venting system. That will tell the unit to change its RPM of the blower when it's running, and that will make the system run properly. Multiples, we can do multiples. Right out of the box, this comes with this gray cord. This gray cord gives you the ability to tie 4 of these units together, daisy chain them together. It becomes a parent-child type situation, and we just daisy chain them together. We tell this one it's the parent, dip switch, plugs in and out right here, parent, right? And you're going to plug this one, will tie to the next one. Out of the next one, it'll go to the next, to the next, to the next. You get 4 of them. We can tie up to 20 of these together with one controller. So depends on what type of job you're doing. You got a hotel, whatever it may be. You have the options of going tankless. So up to 20. From a venting standpoint, we now have the ability to common vent. All right, there's an adapter you get on here with a check in there so that you can't exhaust into any of the heaters within the space, and you have the ability to exhaust multiple heaters through one common hole, let's say a 6-inch termination. So we can do multiples from a connection standpoint to have them work with each other. We can do it from a venting standpoint, and we also have what's called a rack system. We can have 2 up to 6 on a rack system and support hot water needs for a small commercial building, a large commercial building, could be a large residence, a lot of hot water demand. We also have some alternative piping methods that will allow you to tie this into a tank. We actually sell this on a 119-gallon storage tank. Okay, it's a 1-piece unit, and this makes the hot water. We store it in the 119-gallon storage tank, and then you draw out of the tank, and then we replenish it with the ATI 540. We have alternative piping methods where you pipe these primary, secondary, reverse return with storage tanks. Depending on the size of the building, depending on the storage tank, we're doing some hotels. We've done some schools. We've done some condo complexes where we're putting these because a lot of times in these high rises, the mechanicals will be on the roof, and instead of having to rent a crane and shut a street down to carry the new water heaters up onto the roof and put them into the buildings, we can take this and go right up an elevator. So a lot of times this is a good option for those type applications. Just get you thinking outside of the box, outside of the norm. The control itself, pretty robust. It's coated, so it's kind of waterproof. Dip switches, 4 little black buttons down here along the bottom. If you're ever in the field and you're having a problem with combustion, you're on the phone with A.O. Smith, we have the ability to adjust the gas. We also have the ability to reset a hard lockout here by pushing the buttons. It'll reset a hard lockout. Any of the soft lockouts, majority of the lockouts you'll be able to do with the on-off button. But if it's in a true lockout, it says I'm not going anywhere. We're going to go to button 3 here and push that. Hold it in about 3 seconds. It'll reset it. We also have a surge protector built in. So this will protect you You know, these are 115 volt units, but it'll protect you much further out than 115 volts. They come with a plug, you know, typical appliance type cord, 3-prong appliance cord. So that's nice. And the controller, you know, is easily removable. You're not going to do a whole lot in this box. And we just don't see a lot of issues with this control. I'm working on these things 9 years now. I've replaced one of these in 9 years. So pretty robust. Not a lot of, I haven't seen a lot of failure there. So again, we'll protect you. Now back to the control. You just do an install and you want to know how this thing is going to perform. What I like to do, and we always recommend to our guys that are installing these, is you take the control that's normally in this position and you go somewhere in the home, usually a bathtub or something, and you open it up to full capacity. And you put your unit and you monitor the flow. And that flow is going to tell you, brand new unit, this is my flow rate. What we recommend is you take this control, flip it backwards, and on here you put the date it was installed, you put the flow rate and where you took that flow rate, downstairs bathroom tub. If I'm the next guy that comes in behind you and you got the product preserver and I'm there to do a service, I'm going to change out the product preserver cartridge. I'm going to take and look at the back of this controller and see what that initial install looked like, what the test was. And based on that test and the gallons that you put on there, I'm going to run that same test. And if I'm a half a gallon below what your test was, that tells me that this somewhere in here on the water side, I'm dirty and it needs to be flushed. Okay, so use this as a tool. The homeowner really will never see that because it's behind here. This is what it looks like closed up. That's why I left one with the jacket on. This one with the jacket off. You wrote on the back side here, the homeowner won't see it. But now it becomes a tool for you as a service guy. It becomes a tool. The control itself is super easy. We're going to go through that in a minute, but while we're right here in front of this one, we'll go through if you had that half a gallon less flow than you did the day it was installed. The goal would be then to shut off your mains. Okay, shut off your mains. Let me get this cord out of the way so you can see it a little better, I hope. So I shut my mains, my hot, my cold, I shut them down. I'm going to take and I got a bucket. It's on here with, oh, there we go. Thought that was on there with a pair of pliers. I thought one of you guys played a trick on me this morning. Not that anybody would ever do that. No, never. Okay, so you would have a 5-gallon bucket, preferably 2 5-gallon buckets, because this is going to be my retirement job, cleaning tankless water heaters. I'm going to bring a bucket with a cushion. I'm going to sit on there. I'm going to have another bucket with a pump. And I'm going to put a little bit of water in the bottom of that pump or the bottom of that bucket. I'm going to take one hose and I'm going to connect it to here. I'm going to take the other hose and I'm going to connect it to here. You can't see the valve, so I'm going to show you. I would take the valve. I would knock the pressure off, take the valve. I'm going to remove the screen. And then I'm just going to put this back in. Okay? So that's hooked. That's right up inside there. So now I've taken the restriction of my screen, and I don't want that screen to pick up the debris and block my flow. Power's off, obviously. I have my hose with my pump going to my cold, and then I'm coming back out. I've already elevated it to 140 degrees. I've shut it off. I'm now going to turn my pump on with that little bit of water, and I'm going to start to flow the water in the cold up through the heat exchangers, back down, and out back into the bucket. And once I get that flow going, then I'm going to start to add my chemical, whatever it might be, whatever your chemical of choice is. It's got to be a a mild acidic chemical. Okay, you're not going to use like a sizzle or a muriatic acid or anything like that. You would just use a vinegar, a lime out, something along those lines. And you would put that in there a little bit at a time. You don't never want to start with full chemical, because if you have debris in the heat exchanger, you have the ability to break that debris loose and plug the heat exchanger. And then you're really in a bad way. So get your water flowing in, start to add your chemical, let it flow through. You may start to see some debris coming out, some different color water coming out. You'll see a greenish blue sometimes, depends on what's in the water. And you'll do that. You'll continue to add your chemical, and you'll run it like that for, let's say, 20 minutes. After you're done running it for 20 minutes, you shut your pump off. You take your two hoses and you reverse them. So we've gone the way the water goes normally. Now we're going to flush it backwards. So we're going to switch the hoses. We're going to flush it backwards, run it for another 15, 20 minutes, depending on what your water is looking like in your bucket. And when you're done, you're going to shut it down. You're going to take your hoses off. You're going to close these valves. You're going to open your cold water main, and you're going to flush everything out of your hot water into that bucket. And you may do that once or twice. After you're done flushing the heat exchanger, you've cleaned the heat exchanger, you've flushed it. You're going to take your cold water inlet. You're going to pull the little black cap out. You're going to pop your screen back in place. You're going to put it in there, and away you'll go. If you use any acid-based cleaner, you may want to go to a sink in a home, open the sink, take some baking soda, put that in the sink. If it sizzles, you still have the acidity in the water, flush it out more. And usually the bathtub is the best, because you get like 6 gallons a minute coming out of the bathtub. Flush it out real good. Make sure everything is good, clean, ready to go. Close this up. Your house mains are open now. Fire the unit back up, and that would be your flushing service that you would perform on a tankless water heater. Okay, and that's going to be brand X, Y, and Z. Okay. This will absolutely positively help with that. That's why I really I don't like to see a tankless going without one of these. And again, it's imperative. Number one failed part on tankless water heaters is primary heat exchanger. And the material is really not, doesn't matter what the material is. It's the minerals and debris that's within a water system that's creating that problem. So have that filter on there, write down your gallons of flow rates on day one of installation, change out your cartridge every 2 years. That may save you from having to flush this. Just looking out, trying to help. So to the control. How does this control work? Again, it's easy if you're working on the same unit every day, all the time, and everything is the same. But you guys out in the field and ladies out in the field as service technicians are constantly working on different equipment. You can't be an expert in everything. If you go to hotwater.com, if you're working on an A.O. Smith unit, that's where you will find all the information for A.O. Smith equipment, hotwater.com. Control on this is really pretty simple. On/off button, it's off. If you want to shut everything down, pull the front cover off, there's another on/off switch right here inside of the unit. That would be the one preferred if you really want to do some maintenance on there. You're gonna start pulling wires apart. So here, I turn that on, my target temperature comes up. If I need to adjust the temperature, I just hit the colder, 115, 110, 105, 100. That's the bottom. I can't go below 100 degrees. Okay, if I want to turn it up, I go it's 5-degree increments. 105, 110, 115, 120. It does not go above 120. It comes from the factory preset at 120. That's kind of like our safety number. If you need to elevate it above 120, if you take and hit the info, and hot button at the same time and hold them. And you see it flashing, went to 125, 130, 135, 140, and that's it with this control, 140. I can purchase a control that'll get me to 160. I can purchase a control that'll get me to 180. But currently, the standard control that comes out of the box maxes out at 140. Now I can live within that 120 to 140 range right now by making an adjustment. But if I take that down below 120, that kicks me out of the controller again. So if I want to go back above 120, I would have to push that info and hot button again, hold them down for that 3 to 5 seconds until it allows me to go back into the control and step up to those hotter temperatures. All right, but we feel 120 out of the box is a good number. So that's my controller as far as up and down for temperatures. Pretty simple. If I want to make it, if I want to know what the machine is doing, if I want the machine to talk to me, I'm going to take and go to the information button because I'm looking for information from the unit. And if I hit the information button one time, it's going to tell me that inlet water thermistor, water temperature entering the heater. If I push it again, it's going to give me the water temperature exiting the heater. That would be my target temperature, 120. And if I push it again, it will give me my flow rate based on what's happening at that moment. And that flow rate is going to be a moving target based upon what's going on in the home. Is it 1 shower? Is it 2 showers? Is it 5 showers? Now, we talked about flow rates earlier, and we're on flow rates right now. I want to clear up a myth that's in the industry. I have the ability to run a tank style water heater out of hot water, right? A long draw, a deep draw. I can pull all the hot water out of that hot water heater in a matter of, let's call it 7 minutes or less, depending on what the draw is. If I'm drawing it off at a rate that the unit can recover, I'm fine. But if I try to do 5 showers in a row out of a 40-gallon water heater, the last 2 people are getting cold showers, right? Tankless water heater, this water heater right here, this will always deliver the target temperature that you're looking for. So we will give you that temperature forever. I may not give you the volume that you're looking for. If you're overdrawing the ability of this, so let's say 70-degree rise, I'm giving you 5.4 gallons of hot water every single minute. And I can do that forever. But let's say I open up a 10-gallon a minute faucet. I will fill that 100-gallon tub, but I'm going to fill it at 5.4 gallons a minute. I'm not going to fill it at 10 gallons a minute. Because the goal of this heater is to deliver the temperature that you're looking for of 120. So that's what this will do at all times. It will deliver the target temperature that you're looking for. It may give you a reduced flow rate, but it will always give you your target. Where a tank style water heater has no ability to do that. You will just draw it out at whatever rate you're drawing it out. And when you get out of hot water, you're out of hot water. This is going to control that. So just think about that for a minute, right? If you got that, 50-gallon jacuzzi tub, 60-gallon jacuzzi tub, that's like walking down your basement, grabbing that tank style water heater or that indirect, going up to that tub and dumping the whole thing in. That's a deep draw. And a lot of water heaters won't handle that. Tankless water heater will neck down the flow rate to deliver the target temperature. Any questions on that?
Not on that, but I do have one question, going back to the AFR.
Yeah.
The question was, is that rod looking at ionization current?
It's targeting temperature. So we're looking at combustion temperature, and we're either going to pulse the combustion blower or we're going to pulse open the gas valve to make sure that that target temperature is proper in the chamber so that it knows it's a clean flame. we speak numbers here. We don't speak English. It's numbers for codes. Internally, if you get deep into the control, and there is a history in here, if you get deep into the control, a perfect flame to this control would be a number 6. If I go out of that number 6 range, whether I go below that or above it, most of the time it'll go above it. If it gets to a number 15, it will become a hard lockout. Okay, so that's what that air fuel ratio rod is doing. It's babysitting the target temperature in the chamber, and based on that, it's going to either pulse combustion blower, pulse gas valves, and it will automatically adjust, and it has a range that it will operate within before it will allow it to shut off. So we took the time to hook all the lines up and everything here. So let's run this thing through some paces. Right here, we have 120-degree target temperature, right? And if I were to walk over here and turn on a shower, and we are going to get in trouble.
Yes, we are.
Pull that green screen out of there so we don't get it wet. Yeah. So the unit has fired, and I'm going to go here. I got one shower on. I got 53-degree water coming in. I have 120-degree water going out. Say hi to Jim DePalma, taking down our green screen. So we're overshooting target a little bit. We're 123 degrees, 122 degrees. It'll reel it back in. That bypass valve is making the adjustment. Normally on these tankless water heaters, it will always be within 1 degree of your target. Okay, so let's go to the next step. I am at 1.4 gallons of flow. I can open up another shower, and it just ramped. It recognized it. Our flow rate is still going. We are on like 75 feet of hose, guys and ladies. So we might be a little pressed to get real high flow rates out of it. But we have 55-degree water coming in, and we are hitting our 120 degree going out. And we are really stressed for water now if there's people in the building. We had a little higher flow rates this morning when no one was in the building, but we're at 2.5, 2.4 gallons of flow. So the unit is modulated down. If we had more flow right now, we could be 5.4, 5.7 with, what was our temperature coming in? So it's 54 degrees coming in. I could tell you, just give me a second here. I'll tell you exactly where we would be if we had greater flow. But we will run and deliver that target temperature until I run this tank out of propane. Okay, so at 55 degrees with this 540, we could deliver 6.9 gallons of hot water a minute forever. Okay, so it's always going to be driven by the inlet water temperature. If I pull that inlet water temperature down where I have to get a full 70-degree rise, that's when I'm going to get down to the 5.4. This is good. See the water dripping out of the bottom right here? This is condensation. So what's happening right now is we have combustion taking place here. We're collapsing the flue gases in this secondary heat exchanger. So our water's going through here. Our flue gases are running across this. And as that's running across there, we're collapsing the flue gases. We're taking that gas, turning it back to a liquid. That's running into our collection tube, down through our condensate trap, and is dripping out of the bottom of the unit right now because we're making hot water. And this unit is condensing. And that's why we can get to those 95% efficiency rates, because we're condensing. Let's see if I can get any higher flow rates right now, 2.7. Again, we could get up to 5.9 gallons per minute right now because of the 53-degree inlet water temperature. Rob, any questions there while we're fired up and running?
Not regarding that, no, but there is, actually, hold on one second, we have one. GPM is shown on the screen when in operation.
That is correct. GPM will be shown on the screen, and it's called on here flow. I'm at 3 gallons per minute right now of flow, 3.1. That means somebody's not using water in the building right now, which is good because we're getting higher flow rates, and we're still easily maintaining 53-degree inlet and 119, 120-degree outlet water temperature right now. So yes, it will always be predicated on, do I see a demand?
Yeah.
Remember, going back to the flow switch, if this flow switch malfunctions, I probably won't get an error code here, because if I can't recognize flow, I have no ability to give you an error code. So now that we have flow, the unit is on. You can see how quiet these are. I don't even know if you guys can hear it coming through the camera. The camera realistically is about 7 feet away from this unit, and we're running, and you can really see it condensing now. The higher the flow rates, the more water we're producing, the more it'll start to condense. So we're at 3.2 gallons a minute. You can see that's some pretty hot water running over there. Jamming out some good hot water. What else you got for questions?
All right, so I actually got 2 questions that are relatively similar. One is, can this unit be piped in primary, secondary, and used as a hot water boiler? And the other one is, can it be used as a combi?
Okay, so we do not have an H stamp on this unit. We do see them used quite a bit as a combi. The goal, if you use this as a combi, you would have to have stainless steel circulator. You would have to be hooked to a device that is a potable device. So if you have an air handler, it has to be qualified as a potable water device. And you have to maintain 2 gallons per minute minimum flow across this heat exchanger at all times, preferably higher, when you run this in heat mode, because we need to exercise the burner. We want to make sure we're using that whole burner. So 2 gallons a minute minimum, and I say minimum. I'd really like to see it in the 2.5, 2.6 range minimum. So you're talking like a 009, 0011, possibly a 0013 circulator, depending on how far away that heating appliance is from this. So that's a great question. We're running into that more and more. What else you got?
I believe that's it for right now. Yep, we're good.
Okay, it is just about 8:20. If you have questions, don't hesitate, throw them out there. We're a few minutes early, so you can get up and get out and go see people 10 minutes earlier than expected. We appreciate everybody spending time with us this morning. Thank you to the crack crew behind the camera. We had an interesting morning, to say the least, but that's like the norm now. If you want to see a recording, or you missed something, or you got in late, you can go to HVACinsiders.com. We are recording this, and we will post it. You probably see it up there early part of next week. Any other questions, Rob?
No, that's it.
All right. Thank you, everybody, from Wells Darby, our shop. We appreciate everybody spending some time with us. Take care.